have a program for the School of Social Sciences in Economics. Specifically, the topic for today that we are going to discuss is the use of mathematics in economics. This is a topic that can be used for several of your papers, several of your courses, and it is a general topic to give you an idea of the applications or the uses to which mathematics can be put in the analysis in economics. To begin, let us first understand the nature of economics, what economics deals with actually, and then we'll also discuss the nature of mathematics and how mathematics can be useful in economics, and also which are the areas of mathematics which find particular use and application in economics. What are the pluses, what are the minuses of uses of mathematics in economics is what we shall discuss in due course. But first, let us discuss the nature of economics and find out whether there is something intrinsic in the nature of economics itself that allows mathematics to be used, and more so in economics as compared to other social sciences. Now, you would think that economics essentially deals with things to do with money. That's the common impression, that economics deals with monetary exchanges, relationships, and things like profits, costs, prices, interest rates, investment, production. These are the words that you hear or that you think of when you hear the word economics. But is it really so? A very famous economist of the 20th century, John Maynard Keynes, once said that economics is nothing but the study of people in the everyday business of life, which means that just about anything that people do in the course of their lives can be thought of as falling within the purview of economic analysis. Economics primarily deals with relationships. It deals with relationships among people. You would wonder how. Well, the obvious way is to look at some institutions where people interact and then see how these relationships develop. Think of a market. Think of buying and selling of goods. There are relationships between the sellers and the buyers, the shopkeepers and the customers, the retailers and the buyers. Similarly, there is a relationship that develops among retailers and the distributors, the transporters. These are some of the examples. Other situations that you can think of is in a factory or in any organization of work where there is an employer and there are employees. There are other suppliers of inputs, other suppliers of raw materials and other resources that go into production. So, all the time there is an exchange, there is dealings, there are interrelationships, and all these fall in the subject of economics. Now, you would perhaps appreciate from all this that when we are dealing with economics, when we are dealing with relationships among people, the central topic that becomes important is the human being himself or herself. Now, why I am saying this is because if you look at the various roles or the various categories of relationships that we just discussed, be it a shopkeeper, be it a producer, be it a seller, be it a buyer, be it a consumer, be it an investor, be it the government, be it the regulators of the economy, be it exporters, be it importers, all these things are nothing but people. So, basically we are looking at the behavior of people and we are seeing what people do and why they do what they do. Now, one of the common features of economics or modern economics is to try and investigate as to the motivations of people as they go about their activities. Now, you are looking at a producer. Supposing you look at the behavior of a business firm and you are looking at the entrepreneur, the producer, now you would wonder, what exactly does she do? What is her motivation for being in business. What is it that she is trying to do? Now, you would appreciate that, and you would perhaps think that making profits, or perhaps increasing sales, or also maybe trying to capture as large a share of the market as possible is an aim. Similarly, when you look at the behavior of a business of a consumer, think of a housewife who goes and has to make a budget for the daily provisions, a budget for the fees of her children, budget for buying other items like clothes or consumer durables. Now, she has to plan, she has to work out, and she has to decide how much to spend and what are the resources available for spending them on, and where from other things can be arranged, whether to take a consumer loan or whether to buy a thing on installment or make a cash payment. All these are actually decisions that have to be taken. So, what we are saying is that economics is dealing with decision making and interactions by people, and we have to see what is the motivation, what is the thought, what is the desire that inform these decisions, what is it that make the decisions be what they are. Why do people behave the way they do? Now, having said this, now let us stop for a while about economics and see what mathematics is and what mathematics can do. Now, when you talk of mathematics in everyday life and you say that somebody is very good at mathematics, the idea is often to say that mathematics, somebody who is good in mathematics is good at calculating, good at additions and subtractions, can think of a huge or large number and take another large number and can multiply one with the other and get the result quickly. That person has a mathematical skill. This is what mathematics is. Well, this may be mathematics, but you would perhaps be surprised to know that not many mathematicians also are very good at these things. Not very many mathematicians, or not all of them at any rate, can off the head find out the answer to say a 10-digit number multiplied by another 10-digit number and tell it to you. They are not better mathematicians because they can do these things faster. No. Mathematics is primarily a language, and this is what we shall elaborate in the course of this session today and see specifically its uses for economics. But first try and understand that mathematics is a language, and as any language, it has its alphabet, it has its letters, then it has its words, it has its rules of grammar, it has punctuations even. So, you use these things to depict a certain situation. That is mathematics. Mathematics also, that is one use of mathematics. Now, you would say, well, if mathematics is a language, why do we need this particular or specific language? We can as well do with, just English. So, for instance, if I am explaining in English, why not just limit yourself to English words? Why do you have to bring in mathematics? Well, the answer is that mathematics is a language, but it is a special language. The advantage of using mathematics is, as you would know if you do many of our courses, and as you must be doing economics courses, you will find in your blocks, in your units, several uses of mathematics. I shall again be talking about how these uses have been put to, and not just the content of what is being explained to your in your courses or units or blocks, but what is a common language of mathematics, what is the common structure of mathematical economics is what we shall discuss now. But please try and understand that mathematics is not merely a language, but a very special language, because it has its rules and it has its advantages. The advantages, as I was about to say, is that once you translate or once you frame a certain situation in mathematical terms, then the logic of mathematics itself allows you to arrive at conclusions invoking the internal rules of logic of mathematics itself. It is a very good deductive tool. That is the basic use of mathematics. The basic use of mathematics is to act as a detective when you are trying to search for the elusive answer or solution to a problem in economics or in many other social sciences, but more so in economics. What I am trying to say is, to put it differently, that you have mathematics, you have a certain depiction or certain scenario that you want to study about everyday life, and what you are doing is you look at the situation. Say you are talking of a buyer buying from a seller. Now you can say this in English and or in any language, and you would just describe a situation to a point. But the advantage of mathematics is when you put this into a mathematical term, then once it is within the domain of mathematics, you can invoke the internal rules of mathematics to arrive at a conclusion. If P, I am just giving a generalized and I will explain this. Supposing you say if a situation P exists, then a situation Q can come. This going from if P then Q or Q follows because of P is because of mathematical assumption. Now you would often hear one of the criticisms as you study economics and as you interact, or if you talk to people who are non-economists, you will often find one of the criticisms being made of people from economics or otherwise is to say that economics makes these assumptions. Economics is very restrictive. You say in other things held constant. For instance, a very simple proposition which you must have studied in your EEC 11 if you have taken, or many other courses, is that if the prices of other goods remain unchanged, if the consumer's income remains unchanged, if the tastes do not change, then as the price of a commodity rises, the demand for it falls. In other words, if other things are held constant, then as price of a good rises, the demand for that good falls. Now somebody might say, why are you making so many restrictive assumptions? If this, if that, why don't you simply say that as price increases then demand falls? No, that is the power of mathematics, that it allows you to not only make deductive statement, but it inculcates in you, it instills within you a habit of making precise statements. You are not saying that prices will increase or as price increase the demand will fall. No, that will only take place if the other things do not change. Supposing the price increases and you would otherwise have reduced the demand for good, but in the meanwhile you get a large windfall of money, your income, you suddenly inherit a lot of wealth, then you are a rich person. Then even if the price of a good rises, you might still consume more of that good. So the demand has not fallen. So to make precise statements is the power of mathematics. So when I say that mathematics allows you to make precise statements, that is the power, that is not a limitation. In fact, you will often find when you and I sometimes talk or discuss in general terms about any topic, for instance, not just economics, you are talking, people love to talk about political situation in the country, about sports, about a lot of things. When someone makes a statement, then you say, no, does this happen? Then the person pauses for a while, no, what I mean to say is this, no, not that. People are making always imprecise statements. When you frame it in mathematical terms, you make precise statements. That is the first advantage of mathematics. Secondly, as I said, once you frame a situation in a mathematical language, then the internal logic of mathematics allows you to arrive at a solution which you otherwise might not have got. A very simple example from blocks 2 and 3 of your course EEC 11, Fundamentals of Economics, is when you are talking of the decision making by a producer or a consumer. Let us say the decision making of a producer. Now one of the great uses of mathematics that has come about and which has provided an internal solution is to look at the behavior of a producer. Now when we say in general terms, in real life, we say that, well, a producer is making a good and well, he wants to keep a 10% profit rate. Usually in this industry, they are happy with a 20% profit rate. The profit margin is very small. that kind of thing. But if you think logically, rationally, a person who is in business would ideally want to make as much profit as possible. That is the idea. I mean, who wouldn't want more profit? Or if you are a consumer, you would want to maximize your utility. Now, here please try and understand, I will just digress for a while before coming away. Please try and look at these two situations. One is a producer and one is a consumer. We are saying the producer wants to do the best he can in his business. The consumer wants to do the best she can in her day-to-day activities. And we are giving them a behavioral assumption that they want to do the best they can. In other words, once you translate it into mathematics, you say they have an objective function. You remember what a function is? Function is nothing but the dependence of one quantity on one or more of other quantities. When you say output depends on labor and capital, you are saying output is this is a production function. When you say as a consumer your utility depends on the consumption of various goods, the combination of various goods give you a certain utility, then you are saying utility is a function of these goods. That you understand. Now, herein again is a power of mathematics that I will just say, and which is sometimes misunderstood by non-mathematicians or those of your friends who do not study, are not doing economics. People think of mathematics as being able to deal only with quantitative terms, with numbers, which actual amounts. And somebody says, well, the real life is not like that. You can't, how do you know how much profit that person is making? How do you know how much that utility that person is getting? So, people assume that once one talks of mathematics, most people have arithmetic in their minds. They think of a number like 50,000 or 25 or things like that. Once they assume that if you can't get these precise numbers, then it is useless to talk of mathematics. Not so. Although profit is something that you can actually measure, you can go out and say, well, this year this firm made this much profit, but you can't do that with utility. But the beauty of mathematics, and mathematics, why mathematics, I don't mean only arithmetic. As you have seen in your course EEC 5 on mathematics or EEC 11, there is a branch called Algebra, that is, and you have other branches which allow you to deal with a quantity that we say variable. You just depict, let us say you depict an output by Q and labor by L and capital by K. Now, all you write is an equation which says Q is equal to, put a bracket and within that bracket put K comma L. Now, it just looks like a equation, but it is not actual numbers. It is not say the left hand side is exactly equal to the right hand side. What it says that that symbolism of F and that bracket within bracket this K and L, what this tells you is the English language. If you translate this thing into English, then you will say, well, output depends on the use of capital and labor. Now, this sentence if you were to translate into mathematics, you will write Q is equal to F, K and L. Now, this is an example of a translation from English into mathematics. But to get back to the point, what I am saying is, if I just consume two goods X and Y, and I depict utility with U, then mathematics allows me to, just as I wrote a output function, mathematics allows me to write a utility function by simply writing U is equal to F within bracket X and Y. Now, it does not matter that U has no specific number. All it tells me is that my utility depends on consumption of good 1 and consumption of good 2, and I am saying that for the present analysis I am not talking about consumption of any other good or any other factor. All I am focusing on is consumption of good 1, good X and good Y, and this combination of these two goods gives me a utility. Now, to come back to the use of mathematics, as we were talking about the decision making by a producer or by a consumer, the common sense made us suggest that the producer would like to do the best he can, or the consumer would like to do the best she can, and we say therefore in mathematical terms that the producer wants to maximize his profits and the consumer wants to maximize her utility. Now, having said this, there is a branch of mathematics called differential calculus that allows you to study situations of optimization, of situations where when you have a function, the highest point or the lowest point or the maximum point of that function is to be obtained. Differential calculus gives you that situation. Now, the beauty of mathematics is that differential calculus can be used in physics, and with certain appropriate use it can be used in economics also. So, mathematics, please remember, as a famous economist Paul Samuelson once said, mathematics is a very good servant but a very bad master. If economists use mathematics as a use, as an application, then it is fine, but once they start thinking only in mathematical terms and lose the inherent logic of economics, then it is very difficult to distinguish between mathematics on the one hand and economics or physics or other things on the other hand. Then you do not know what is being studied. So, the topic under discussion is the most important thing. Again, to come back to this, and I was talking about differential calculus, there is a branch which you have studied in your blocks, later blocks in course EEC 5, those of you who have taken, and also the applications of this you have seen in courses EEC 11 and EEC 12. When you talk of the decision making of a producer or a consumer, is precisely this. Once you have a differential calculus, then there are rules, what are called first order conditions and what are called second order conditions. You differentiate the function, set it equal to 0. There are reasons for doing so which I am not going into. The idea is that once you get that, this is called a marginal solution. Marginal does not mean insignificant, marginal means the producer, to say this in terms of the producer's decision making, differential calculus allows you to say that the producer will produce that quantity of output. In order to maximize his profits, the producer will produce that quantity of output where each additional, after this, each small incremental increase in quantity produced, the revenue that he gets is exactly equal to the cost that he incurs. Up to the point, below that point, there is a greater chance of incurring revenue and a small chance of revenue will increase faster than cost. Beyond this point, cost will increase faster than revenue. This is exactly the point where the profit is maximized. Now, this solution could not have been arrived at a simple English or just argument, in terms of the information produced. It is a direct invocation of a mathematical tool called differential calculus that gives you a solution, which after that when you translate into English, you would say the producer will keep on producing till he reaches the point where each incremental, each additional or each marginal increase of output gives an equal makes the marginal increase in revenue equal to the marginal increase in cost. Now, this marginal thing came from differential calculus. Please remember that in the late 19th century, there was a group of economists who for the first time started applying differential calculus to study the behavior of producers and consumers and other decision making, and they invoked differential calculus. Differential calculus is a technique invented by Isaac Newton and also independently by Leibniz to study the behavior or to study the motion of planets and to study the laws of gravitation. It is used in physics, but the beauty of it is that it helps you to study inanimate objects like the planets and their elliptical motions and relationship between one heavenly body and another, and the same tool allows you to study the behavior of a producer or a consumer. So, they used differential calculus, they arrived at a logical framework and a logical piece of analysis of the behavior, and because they said in conclusion that the output will be produced, that quantity of output will be produced after which the marginal revenue, or at which the marginal revenue would be equal to marginal cost, and similarly the consumer will keep on consuming that unit or that amount of unit where her marginal utility or utility at the margin is just equal to utility, disutility that is the point at which the consumer stops consuming. So, which means the consumer consumes to that amount at which marginal utility at the margin is just equal to the price that she pays. So, because these solutions from differential calculus were arriving at in terms of marginal utility, marginal cost or marginal revenue, therefore, these group of economists came to be called the marginalists, and this whole approach to economics came to be called the marginal revolution economics, because nobody prior to this had thought of economics in this sense. So, please try to appreciate that this thing came about from the internal logic of differential calculus. To give you another example, so what we are saying is that once you see the relationship between one variable with other variables, you invoke a mathematical technique called function. Once you put mathematics in different groups, you can invoke the mathematical technique called set, relations and functions. Once you see how change in one of these can induce a change in another thing, then you invoke differential calculus. As you study the different topics in your courses, you will find that different branches of mathematics are being used. So, once you do that, then you will get an understanding of how mathematics is being used. Now, secondly, mathematics is a situation or a tool or a set of tools that gives you, not just makes your language precise, that we have said that is the first use of mathematics, first advantage of using mathematics. Secondly, it is not just a situation of giving you a set of conclusions from premises, that we saw was the second use of mathematics. The third use of mathematics, and this is its beauty. One thing also additional we have seen is that mathematics is not limited to arithmetic or numbers. It is a general relationship, or it is a study of relationship between variables, between different sets of variables, between different ways of depicting situations. Now, let us say you say that as labor increases, the output increases, and throughout the relationship is such that if labor is increased at every 5%, or say each additional output of labor increases output by 1 unit. So, 1 unit of labor, 1 unit of output increases, 1 unit of labor increases, another unit of output increases. This is what is called in mathematics a linear relationship. If you make a graph of the relationship between labor on one axis and output on the other axis, you will find a straight line. So, this is just an illustration to bring home the point that mathematics provides not only a set of tools to discuss and describe and analyze different economic situations, but the beauty is that it provides a huge range or an array of techniques. There is a different technique to describe different situations. When you talk of relationships, if you don't want to bring in differential calculus, if you want to just say this plus this adds up to this, and the relationship between them is linear, you can use a branch of mathematics called linear algebra. It is a branch of mathematics called linear algebra, and you discussed things like matrices and determinants. An application of that is in making, when you say the plan models of India are made, when the government of India has to discuss the relationship among different sectors between the steel sector, the coal sector, then you discuss linear algebra. So, what we are saying is that mathematics uses a set of tools to discuss different situations. Now, let us go over again the nature of economics and the nature of mathematics. Before we proceed further, let us just revise what we have done. We have said that economics is the study of people going about their everyday business of life, and we have said that mathematics is a language. So, what we are basically saying is that mathematics is the application of a particular language to study the behavior of people as they go about in their everyday business of life. Now, I said in the course of our discussion that one of the assumptions that economics makes is that people want to do the best they can and they want to maximize that. Even the mathematical equivalent of it is that they want to maximize their objective function, be it as a producer or as a consumer. Now, there is no unanimity in economics that this is indeed the case. There have been times in the study of economics, or there are different schools of economics which do not believe that people do the best they can. So, therefore, they do not invoke differential calculus. If they do not invoke differential calculus, as I said, the beauty of mathematics is they can invoke some other branch of mathematics once they depict a certain situation, or once they impute a certain behavioral pattern on individuals which may not be maximizing behavior. They can still use mathematics to deal with that situation. Indeed, you might be interested, there is a school of thought, Marxism, and there are Marxian economists who naturally do not believe that people want to do the best they can, or they have a value judgment that people, even if they can do the best, should not do the best because it may not be morally or ethically defensible. So, once you have that point of view, then even so, to depict those propositions, it is possible to invoke branches of mathematics, and as I was saying, linear algebra is a branch that has often been used. There are branches of mathematics which we have not dealt with in your courses, which are more advanced, which other more advanced mathematicians study, which are used by some economists, but you need not use them. So, what I am saying is that mathematics can be of various types, various branches of mathematics are there, and depending on the situation you can use a different type of mathematics. But what exactly are the limitations of mathematics? We have been saying about the uses of mathematics, but what is the limitation? The limitation of mathematics is this, that mathematics, you must understand, is like the spectacles, like the glasses. A spectacle can, if a person has impairment of vision, the spectacle can improve the vision. But unfortunately, if the person is visually impaired, the spectacle cannot impart vision or cannot improve vision in that situation. So, as I gave the quote earlier by Professor Paul Samuelson, in economics, mathematics' use should be kept in view, that mathematics is a good servant but a bad master. If people think that mathematics itself will provide the topics as well as the basic scenarios and situations in economics, they would be mistaken. Mathematics can provide a language and it can provide a tool, but it cannot provide the basic intrinsic topics of economics. In conclusion, I will just say and add that we have talked of mathematics as a deductive tool. There is a branch of mathematics which is called statistics, and which is something like an experimental things that scientists do. Economists are constrained, they cannot carry out experiments in real life because people go about, they are not in laboratory situations, but statistics is a branch of mathematics that allows you to do inductive study, in the sense that first you study the individual cases, you add up, arrive at a conclusion, and then arrive at a law. We had discussed the law of demand in the earlier part of a program. We said there is a deductive law, but an inductive way of arriving at it, or a statistical way, is to actually take a lot of people, observe their behavior in situations where the other things do not change, and if the price increases, whether the demand falls or not. If the demand falls, then you say inductively that this law holds. So, you build up examples and then you arrive at a law. That is called an inductive way. The deductive way is to begin with a premise and to see logically within the parameters of that analysis whether you come to that situation or not. So, I will end the discussion here, and I will remind you that mathematics is a language. It is a language of precision, it is a language providing tools of deductive logic, and it allows you to use various branches of itself. It lends itself to various kinds of analysis, so that you can analyze different situations in different times. Thank you. I hope you have gained a little from this program. Anything that you think of or any question that arises in your mind, you are free to write to us at the faculty, the School of Social Sciences in Indira Gandhi National Open University. Thank you very much for watching this program. Thank you.